find the 5-number summary from the data set shown in the table below. And after that, we have some questions about which of these values, if any, are outliers. So let's work this out. So first off, to do the 5-number summary, we're just going to take advantage of our calculator and allow it to find the value of the minimum, median, maximum, Q1, and Q3 for us. All right, so we'll go under Stat and Edit to get to our list editor. If you have anything in there already, go ahead and clear that out, of course. And put your data set into L1. Now notice that the entire data set will go into L1, and you won't put anything in L2 because there's no indication of frequencies here. So these are just individual data items within a data set. So enter them, and once you're done, make sure you go back and double check to make sure you got the right ones in, because if you do the process in the calculator correctly, the only real way of making a mistake here is typing in your data improperly. So just double check it when you're done, make sure everything looks correct. All right, now we'll leave the list editor, press Stat again, come over here to one-var stats, and since it's just one set of data and there's no frequencies, we don't need to put L1, L2. It will default to L1, so I can just leave it blank there. And I have my 5-number summary, but I have to scroll down to see the values of it. So min x is, of course, the minimum data value in the data set. And in this case, that is 10. So that's our answer there. Q1 is given to us as 37.5. The median is 44. Q3 is 50.5. And the maximum is 81. All right, so that's the 5-number summary, and the calculator comes up with that for us. Next up, what is the value of the interquartile range, so IQR? The interquartile range is an alternative to the range of a data set, and the range is, of course, the maximum minus the minimum. The interquartile range is Q3 minus Q1, so it's in the same fashion, but it's just using values that are less likely to be outliers. In this case, we would take 50.5 minus 37.5, and if you need to use your calculator, that's of course recommended so that you don't make an arithmetic error. It looks like we have 13 in this case. Okay, now the next thing that we need to come up with is the lower bound for an outlier, the upper bound for an outlier, and list any values in the data set that happen to be outliers. So outliers, generally we just think of outliers as data values that are much larger or much smaller than the rest of the data set. So in particular, to define an outlier, one way we can do that is say the value of Q1 minus 1.5 times the interquartile range is a lower bound on an outlier. And then Q3 plus 1.5 times the interquartile range is our upper bound for outliers. So we could have values that are much larger in general than the rest of the data, so those would be larger than the upper bound, or much smaller than the rest of the data, and those would be less than the lower bound. So we need to compute both of these. All right, so the lower bound, so I'll just say LB, that's going to be Q1, which was 37.5, minus 1.5 times the interquartile range, which we calculated as 13. So let's take a look here. So 37.5 minus 1.5 times 13. That is 18. So any value in the data set that is less than 18 would be considered an outlier. Now the upper bound, which I'll just call UB here for short, would be 50.5, my value of Q3. I should write where those numbers are coming from. So 50.5 plus 1.5 times the interquartile range. So 50.5 plus 1.5 times 13. That is 70. So any values that are greater than 70 are also considered outliers. So the lower bound is 18, the upper bound is 70. The minimum data entry is 10, so that means that value itself is at least an outlier because it's less than 18. But scanning through the data set, that's the only lower outlier that I see. And the upper bound is 70. Since the maximum is 81, that means 81 is at least an outlier. But I also see 77, and that might be it. Everything else looks like it's in the 60s or lower. So then 10, 77, and 81 are all considered outliers in this data set.